Today we will be looking at the chapter Number Play from grade 6. In this chapter we will be looking at how numbers play a very good role in our lives, how numbers can be used in our lives in different ways. So the first topic in this chapter is that numbers can tell things. So what does this mean? Numbers can tell us various things. For example, in this picture you can see many children lined up and they exclamate a number. And there is a pattern. If this kid is saying 2, that means next to her there are 2 kids who are taller than her. This kid is saying the number 1, that is only one kid is taller than her. And the saying goes like this. See, this kid says 0 because there is no one taller than this kid. That tells us a number can tell us various things. For example, in this case, the number is telling who or how many people are taller than them and are standing next to each other. And then the next topic is supercells. Now, if you observe the same pattern like over here, you can see there is a whole row with colored numbers. And if you look, you can see the colored number or the colored cell is having a number greater than both of its sides. So if you look here, 43 and 75 are lesser than 79. That means 79 is greater. So that means a cell is colored. See, a cell is colored if the number is larger than its adjacent cell. So this is what this tells. In the same way you can see here. Now color or mark the supercells in the table given below. So here this will be colored, and when you look at this style it won't be colored because both of this are greater than this. Then this will be colored because this is greater than both the adjacent cells. And then when you look here, nothing will be colored, nothing will be colored. This will be colored because both this is greater than both of these. So this is how the pattern goes. Now when you look here, fill in the table below with only 4-digit numbers such as that the supercells are exactly the colored cells. So supercell is a cell in which something is greater than adjacent cells. So if you write here 7000, you should write a number less than 7000 and this is less than 7000. So this is fine. So here 7000. So this is how the pattern goes. Now in this table also you can see the supercells always have a greater value than its adjacent cells. See, this has a greater value than 2430, 7350 and 4795. This also has greater value than this and this. So this is how the pattern goes in these kind of questions. Next we have patterns of numbers on the number line. So number line is a line consisting of different numbers. In this line you can see the numbers from 1000 to 10,000. And you can see there are many digits in between now. Now, if you're looking for the number 1500, it will be exactly in the middle of 1000 and 2000. So this is how number lines are supposed to be. Now, if you're doing these kind of questions, here you can see 2010, a line, and 2020. Now, if they're telling to mark these numbers, then you'll mark it in this way. 2010 and 2020. What is supposed to be in between them? 2015, so 2015, then 2020, 2025. So this number line has a difference of 50. See, like this, 2010, 2015, 2020, etc. This has a difference of 5, not 55. Oh, like that. In the same way, 9996, 9997. So the next digits would be 9998, 9999, and so on. So this is how the pattern should be done. Next we have the topic playing with digits. So in this way you can find out how many numbers have 2 digits, 3 digits, 4 digits and 5 digits. For example, 1 digit numbers from the numbers 1 to 9. We know 1 to 9 are all, there are 9 1 digit numbers and 10 is a 2 digit number. Now over here you can write 2 digit numbers from the number 10 to 20, and then you can write all 10 of them have, because 10, 11, 12, 13, 14 all the way to 20 have 2 digits. So this is how this pattern goes. Next we have digit sum of numbers. For example, when you add the digits of 68 and 176 or 545, you will get the same value. Like 6 plus 8 is 14, 1 plus 7 plus 6 is 14, 5 plus 4 plus 5 is 14. So this is how the digit sum of numbers work. With that concept, you can find many numbers having digit sum. For example, write other numbers whose digits add up to 14. Add up to 14. So that is 14 can be 151. No, 151 will be 5, 6, 7. No. So you should have digits that will add up to 14. One example is 77. When you add 7 and 7, you will get 14. And then is 68. That is 8 plus 6 is 14. So that is how you do this kind of questions. The next topic is pretty palindromic patterns. Palindromes or palindromic numbers are the numbers which read the same when you read it from left to right or right to left. For example, you can see here in the number 676. So when you read this number from left to right, it is 676. When you read it from right to left, it is 676. Another example is 66. When you read from this side to this side, it is 66. This side to this side, 66. So this is called as palindromic numbers. There are different types of palindromic numbers. All palindromes using 1, 2 and 3, that is 121, 313, 222. These are all examples of palindromes using the digits 1, 2 and 3. The next quality of a palindrome is whenever you add palindromes, somewhere in the addition step, you will get a palindrome. So 34 and 43 are palindromes. And when you add it, you'll get 77. 29 and 92, you'll get 121. This is how you get palindromes. The next topic is the magic number of Kaprekkar. So Dr. Kaprekkar was a mathematics teacher in a government school. So one day while he was looking at numbers, he found a playful pattern, and that is with the pattern of 4-digit numbers. So what he did was he took a 4-digit number. For example, let's take the number 6382. Now what you do with 6382 is you make the biggest number you can make from 6382. So the biggest number is 8632. That's the biggest number. Then you make the smallest number. That is 2368. That's the smallest number. Now what you do is you go all the way and then you subtract this from this. So when you subtract this and this, you'll get a number. Now you continue the same process. That is, take the biggest number of this and the smallest number of this digit and find out the value. Next, take this value and do the same process, and somewhere while doing this process, you will get the number 6174. This is known as the Kaprekkar constant because Kaprekkar found out that whenever you take 4-digit numbers and you do this pattern, you'll always somewhere you will get the number 6174. So this is known as a Kaprekkar constant. The next topic is clock and calendar numbers. So we know in clock and calendars we use numbers, and all these numbers have different patterns. For example, 444, 1010, 1221, and in clocks we find 1111. So these are all patterns in a clock. Now another example is in the calendar. In calendars you can see 2012, 2012. That is 2012, 2012. But then when you look 2012, 2012. So it's appearing in a pattern. Another example is 11 to 2011. When you reverse this 4 digits, you will get 2011. And when you look at 2011. So this is also a pattern. So these are how patterns appear in calendars and clocks. Then the next topic is mental math. In mental math, what you can see is if there's a middle block and there are 2 different columns on the sides. So what you do is with these numbers, when you add certain numbers, you can get the values. For getting 3400, if you add 1500 and again 1500 and add 400, you will get 3400. 1500 plus 1500 is 3000, and then one more 400 will give you 3400, and this is called as mental math. Over here is the same. See, to get 3400, add 1500, 1500 and 400 to get the value. So this is how mental math works. So these are the questions that can come from this topic, that is 5-digit number plus 5-digit number to give a 5-digit number more than 90250. So the question is you need to add a 5-digit number with another 5-digit number to get a 5-digit number which is more than this 5-digit number. So that is, you can take any number, that is 30501 plus 379 10, no? So 6030. When you add this, you might get a value more than 90,250. So that is this question. And these are different various questions in which you can try out, and this is how those kind of patterns and numbers work. The next topic is playing with number patterns. So numbers are seen in various patterns. For example, this. How do you add all these numbers together? An easier way is either you can add columns one by one. That is 50 plus 50, 40 plus 40 plus 40, 50 plus 50. Instead of that, what you can do is 40, 40, 40, 40. How many 40s are there in the first row? There are 4 40s. So that is 40 into 4 plus 1, 2, 3, 4, 5. 5 50s. So 5 into 50 plus 1, 2, 3, 4. So 4 into 40 plus 5 into 50 plus 4 into 40. So this is how you can add in a quicker way. So these are how number and patterns work together. The next topic we have is an unsolved mystery, the Collatz conjecture. So what this mystery is about is, in 1937, a German mathematician, Lothar Collatz, stated that whenever you take a whole number, suppose 12, and then you subtract it. So if 12 is an even number, you divide it by 2 and you'll get 6. So 6 is again an even number, you divide it by 2. Then you get 3. Now 3 is an odd number. So what do you do when you get an odd number? When you get an odd number, you multiply the odd number by 3 and add 1. So 3 3s are 9 plus 1, that gives you 10. Now 10 is again an even number, so you half it, you get 5. Now 5 is an odd number, so you multiply 5 with 3 and add 1. 5 3s are 15 plus 1 16. So when you keep on doing this, you'll get the number 1. So Collatz stated that whenever you take a number and you do that pattern, you will get 1. So this is about that mystery. The next topic is simple estimation. So what do you mean by simple estimation? Estimation is when you just take a number and you think of a number. That is, if in your class there are 35 students, you can take the total as 50. So it's easier for calculations, because if there are 10 total divisions of your grade, so there is 6 in 6th grade, there are 10 divisions, that is 6A, 6B, 6C. So when you go like that, if you are taking each class, that is, suppose 32 students are there in A section, 36 students are there in B section, instead of that, to make the calculation easier, you can take the number 50 for each class. So if there are 10 divisions of grade 6, there are a total of 500 students. So this is how the calculation can be easier, and that is called as estimation. The next topic is games and winning strategies. So numbers can also be used to play games and develop winning strategies. Game 1 is called 21. In this game, the first player tells the number 1, 2 or 3. So if the player says 3, the second player can either add 2, 1 or 3 to it. So 3 plus, suppose I'm adding 3. So 3 plus 3 is 6. So if this player said 6, then the next player should add something with 6. So the player to add something to the number the last player told and get 21 wins. So these are how games and winning strategies in which numbers can be used. So numbers are helpful in various ways. So this is the chapter number play of grade 6. Let's look at the summary and end this video. So numbers can be used for many different purposes, including to convey information, make and discover patterns, estimate magnitudes. Magnitudes is nothing but number. Pose and solve puzzles and play and win games. Next is thinking about and formulating set procedures to use numbers for these purposes is a useful skill and capacity called computational thinking. Computational thinking is when you use numbers to solve patterns or make patterns. Next is, many problems about numbers can be very easy to pose but very difficult to solve. Indeed, numerous such problems are still unsolved. Example is Collatz conjecture. It's still a mystery. So this is the whole chapter, number play from grade 6. If you like this video, please like and subscribe to the channel and follow for more videos.